Hi, today we're going to have a look at the first of a three-part series that looks at gravity-based deployment mechanisms. These mechanisms are often used by rocketeers in early designs to try and deploy a parachute and detect apogee. So the first of the mechanisms we're going to have a look at is just a freely suspended weight on the end of an arm. And normally the way this would get used on a rocket is you would mount it this way and then put a trigger mechanism that would actually deploy the parachute above the weight. Then as the rocket takes off, it flies, and as the weight swings around and touches the trigger, it deploys the parachute. So that looks pretty good in theory and looks like it's working on the ground, but that's not actually what happens. The other mechanism often employed is just a simple tube with a weight inside it that's freely suspended. And again, the way that's mounted on the rocket is like this, with the trigger mechanism at the top. So when it tips upside down, the weight activates the trigger. So let's have a look. Again, as we tip it, it should activate. So what we'll do now is mount these two mechanisms inside the microlab, and we'll see how it goes in actual flight. So here we have the two mechanisms mounted inside the microlab. We've had to put the camera further outside with a wide angle lens so that we can see more of the experiment and also see through the clear back some of the horizon in the background.
The top of the rocket has a parachute deployment mechanism controlled by a timer which is independent of the experiment. Underneath it is the microlab, and we also have a logging altimeter to correlate the altitude to the onboard vision. So let's have a look at the first launch.
Is it in?
The rocket is filled with 2.6 litres of water and has a 16mm nozzle. And it's pressurized to 110 psi.
3, 2, 1, go!
We delayed the parachute opening time so we can see what happens to the experiment at apogee. Let's have a look at the onboard footage in real time. Now let's slow it down and have a close look at both the camera view as well as the altimeter plot. Here you also have the rocket's orientation for comparison. You can see that shortly after burnout, both the free hanging weight and the weight in the tube move upwards and stay there through apogee until the parachute opens. As the rocket slows down near apogee and there is less drag on the rocket, the hanging weight is essentially in 0G relative to the rest of the rocket. You can see this through the greater swings. Now let's repeat the experiment. Although unplanned, it shows what happens over an entire ballistic flight.
3, 2, 1, go! It's got a late open. Oh. Very late.
Here it is again in real time. And once again in slow motion. The weights fly up just after burnout and stay there until impact.
So you can see from the video that these mechanisms can't be used for detecting apogee, but they can be used for detecting burnout. If you want to find out why the weights do what they do, go to our website here.